Welcome to clickmyproject.com. Now we are going to see the paper Predicting Quality of Service for Selection by Neighborhood-Based Collaborative Filtering. Web services are software components designed to support interoperable machine-to-machine interaction over a network. With the number of increasing of web services, quality of service, that is QoS, is usually employed for describing non-functional characteristics of web services. With a growing number of alternative web services that provide the functionality but differ in quality properties, the problem of selecting the best performing candidate service is becoming more and more important. The composite service is composed of several abstract services, and each abstract can be achieved by a set of functionality equivalent concrete services. The goal of QoS-based service selection is to select candidate services from each set of concrete services to satisfy end-to-end QoS requirements and to optimize composite QoS. There are a number of studies about QoS-based service selection are presented. Their common premise is that the QoS values of all candidate services to target users are known. However, it may not be true in reality. Due to some factors, the QoS of the same service to different users may be different. We propose a neighborhood-based collaborative filtering, that is CF approach, named ADF, to predict the unknown QoS values. ADF denotes adjusted cosine, data smoothing, and fusion of similarity results, which are three new features of our prediction approach. As users in a near region or similar network environment appear to have similar QoS of the same service, we use existing QoS data to compute user similarity and predict the unknown QoS values according to the corresponding QoS values of similar users. Service-based prediction can also play an important role in the final result. Different from previous research of service-based prediction, in ADF, we propose to use A cosine equation, which takes difference in QoS scale between different users into account to calculate the service similarity instead of using the Pearson correlation coefficient approach. In existing memory-based prediction approach, the scalability problem is a main drawback. This paper presents a two-phase neighbor selection called TNS strategy to improve the scalability of our proposed approach. To improve the accuracy of QoS prediction, we propose a neighborhood-based CF approach called ADF, in which the A cosine approach, the data smoothing process, and the similarity fusion approach are adopted. Then we propose a TNS strategy to improve the scalability of ADF. Next, we see the flow diagram. First, we collect the QoS dataset. In this dataset contains the records of web service invocations executed by distributed service users on different web services. The record of each invocation contains two parameters, that is response time and throughput. Next process is similarity computation. Given a dataset consists of m service users and n web services, then we compute the m cross n matrix, which is called a user service matrix. An entry in this matrix represents a record of invocation. Next, we calculate the user similarity. User similarity means we calculate the similarity between each user set. In the user-based CF approach, PCC is used to define the similarity between two users based on the services they have commonly invoked. Then we perform the service similarity. We compute the service similarity for each service using A cosine equation. Next process is similar neighbor selection. We calculate the similarities between different users. In this process, we choose a set of similar neighbors for target users. The process of selecting similar users is crucial for the accuracy of prediction because the prediction of the unknown value depends on the corresponding values of similar users. We find that the QoS values of a user who has very low similarity to the target user are useless or even harmful. The traditional top K algorithm is not suitable for this process. In order to address this problem, we propose a hybrid top K algorithm. Next process is user and service clusters. We cluster all users and services based on the user similarity calculation and service similarity calculation. In the clustering process, we are using k-means algorithm. After calculate the clustering process, we compute the QoS vector. The next process is prediction. In this prediction process, totally 3 types of methods using this prediction: user-based prediction, service-based prediction, and user and service-based prediction. Next, we see the running procedure. First, open the NetBeans and open our QoS project into NetBeans. Right-click load.java and click Run File. First, select Input User List. Click userlist.xls. Then we select the number of web service list. Click wslist.xls. Then click View button. There are totally 11 users and 10 web services. Then click QoS values. Then select the response time and throughput of user and web services. Then click View button. This is the service response time and service throughput. Then click QoS matrix. We construct the QoS matrix of user and service. This is the user and this is the number of services. Null means the user does not occur in this website. Then similarity computation. 2 types of similarity in this process. First, we calculate the user similarity, that is similarity between each users. Then we calculate the service similarity. Service similarity means a similarity between each services. Okay. Then user neighbor selection. Click similar user neighbor. These are the user similar neighbors. Then we compute the user cluster. Totally 3 clusters. Then click the service neighbor. In the same way, we calculate the similar service neighbors and service clusters. Okay. Then we compute the QoS vector. We compute the QoS vector for each user and each services. Next process is prediction. In this prediction, we first calculate user prediction, that is user-based prediction, then service-based prediction, and combine user and service-based predictions. TNS is the second process. First, we select a new username, that is enter new username. Then select the new user list that contains throughput and response time. Okay. Next process is pre-selection. Click View Existing Cluster. These are the user existing clusters. Then we compute the user similarity between this new user and each cluster. This is a similarity value. Then we find the similar user cluster. C3 is a similar user cluster. In the same way, we compute the similar service. View existing service clusters and compute similar services. Okay. The next process is final process is selection. First, we compute the user neighbor and service neighbor. This is the output of our process. Thanks for listening.